So have an extraordinary day, everyone. At this moment, we will be tackle the origin of the chemical elements. So by the way, I am Nasruddin S. Manyal as representative reporter for this topic, the origin of chemical elements. So what is chemical elements? So it's stated here that chemical elements, also called element, any substance that cannot be decomposed into simpler substance by ordinary chemical processes. Elements are the fundamental materials of which all matter is composed. So it means that a chemical element or an element is a material which cannot be broken down or changed into another substance using chemical means. So as we all know that all elements are made up of atoms. Atoms are made up of protons, neutrons, and electrons. When two different kind of atoms combine to form a compound, a molecule is a combination of atoms that cannot be broken apart while still retaining the same properties as the larger substance that it is a part of. So let me give you an example, specific example. The water in the glass. So when we zoom in the water, we can see that water is made up of molecules, and as we zoom it again, we can see that the water is containing some elements such as the hydrogen and oxygen, and we can see the two atoms of hydrogen and one oxygen of atom. Therefore, atom is the most smallest unit of particles or a building block of matter because of its smallest size, which we cannot see it by our naked eyes. Atoms are consist of smallest subatomic particles such as protons, neutrons, and electrons. In atomic model, its center called as nucleus, where neutrons and protons are being located. And when neutrons and protons combine inside the nucleus, it is called as nucleons. The electrons are located outside the nucleus and orbiting. So only 5% of universe today that we actually touch and feel. It's only this approximately 5% of the universe that we are directly aware in our daily life. All of our tangible matter like our stuff, including our bodies, is made of chemical elements. So the solar system is about 4.5 billion years old, while our universe age now calculated about 13.8 billion years. So our best cosmology model has the Big Bang at this time, and the solar system was formed from a cloud of gas and dust that included the debris from earlier stars that had expelled material from within their interior. So the chemical elements that we have before a billion years ago is the chemical elements that we have today. But with an exception of those latest chemical elements were did not yet discovered during that time. So as of now, we have identified 118 chemical elements, and chemists have organized this into chart known as the periodic table. Each square has the symbol for the elements and properties such as the atomic number and mass. So each atomic nucleus is made up of protons and neutrons. So electrons are located outside of the nucleus. So protons have a positive charge, while neutrons have a zero or neutral, and electrons have a negative charge. So there are three important numbers describe the atom. First, the Z, the number of protons or the atomic number; the N, the number of neutrons; and A, the combination of the number of protons and the number of neutrons, or also known as atomic mass number. So, lahat ng atoms na may magkaparehong Z or number of protons are the same chemical elements, and the atoms that have the same Z and A are called isotopes. So, the common isotopes of hydrogen and helium is helium 3 and helium 4. So, later we will know how those elements were being formed. Actually, there are many theories to explain the origin of the universe, but the most sound is the Big Bang. So, the Big Bang theory postulates that the universe emerged from a state of enormous density and energy. Everything came from a single point and expanded to now what we call the universe. So, it proposed by Georges Lemaître, and Georges Lemaître is a French priest, and he was coined for this idea of the expanding of universe. So here the some evidences that the Big Bang theory is the most acceptable among others theories. So meron daw cosmic expansion which proposed by Edwin Hubble, cosmic microwave background by George Gamow, and primordial or also known as the Big Bang nucleosynthesis. So si Edwin Hubble daw ay isang scientist na nag-aaral ng universe, and he viewed that there's an expansion of universe because the galaxies and even the stars are moving apart from each other. And the next is the cosmic microwave, and lastly the Big Bang nucleosynthesis, or also known as the formation of the light elements such as hydrogen, helium, and helium. So, ang pinakamalaking tanong is paano ba tayo nagkaroon ng chemical elements? So, one answer to that is the nucleosynthesis. So, it is the formation of the atomic nuclei or the combination of the proton and neutrons, and it occurs right after the Big Bang. So, pagko-combine or pagsasama-sama ng particles para magkaroon ng nucleus or ng atom. So, it started as quarks forming the protons and neutrons. So, bago magkaroon ng proton at neutrons, meron pang mas elementary particles na bumubuo sa kanila. At tawag nila dito ay ang quarks. So, before we will proceed to the three types of nucleosynthesis, let us first know the stages or the life cycle of the star. So, as we observe that those stars which visible at night and even our sun have their own stages, steps, or life cycle. So, sila'y nagmula sa stellar nebula. So, yung stellar nebula ay combination ng dust and clouds bago pa man nagkaroon ng stars. Nagkaroon muna tayo ng stellar nebula which the stars began and started to form. So, ano yung meron dyan? Merong dust and clouds and elements. So, these elements combined with one another forming what we call the protostar. So, itong mga protostar na to ay mga kumpol ng mga molecules o mga kumpol ng mga elements na pinagmumulan ng mga stars na ito. So, then it can go being into a average star or a massive star. Our sun or the sun which near in our planet ay tinuturing na average star. So, ang path na tinutungo ng sun daw ay balang araw daw ay magiging red giant, and what will happen, magiging supernova para maging planetary nebula, at sa dulo ay maging white dwarf. So, saan mapupunta ang mga matter na meron siya? Actually, it will go out of space. Masushoot siya sa outer space. Pwede rin na after being stellar nebula into a protostar, pwede rin siya maging massive star. It will go to red supergiant, sasabog siya bilang supernova, and it become a black hole or neutron star. So inside a star, merong mangyayari because the main idea the main idea of discussing this topic ay yung energy na ini-emit ng star ay bunga ng chemical reaction na mangyayari sa loob ng kanyang body. So may nangyayari sa loob niya para magkaroon ng tremendous amount of energy. So here the concepts about the life cycle of the star. First, star must have energy to exist for a certain length of time. Second, energy comes from various nuclear fusion reaction between light elements involving the huge amount of energy that keeps the star hot. So like what I have said a while ago, we may be experiencing the energy coming from the sun because there's happening inside it like as nuclear fusion. So when we say nuclear fusion, a reaction between light element involving the huge amount of energy that keeps the star hot. So, balik tayo sa three types of nucleosynthesis. We have Big Bang, stellar, and supernova. So, the first one is the Big Bang nucleosynthesis. So, medyo madali lang to intindihin kasi nangyari siya right after the Big Bang. So, anong nabuo after the Big Bang? So, yung hydrogen at saka yung helium. They are relevant amount of hydrogen and helium. And there are some evidences that lithium was formed through the time of Big Bang nucleosynthesis, but in terms of amount, hydrogen and helium naman ang may napakadaming amount, and up to this moment may napakalaking percent amount ng hydrogen and helium. Because look at the stars naman, they are made up of hydrogen and helium. So itong hydrogen na to ay nag-fuse just to form a helium. So medyo basic knowledge yun about nucleosynthesis and of course the life of the star. And what happens pag may protons, may neutrons nag-combine forming a helium sa Big Bang nucleosynthesis? Makikita na natin about elements ay may isang protons because all species or variety are represent as the hydrogen. For example, when one proton and one neutrons, it produce a deuterium. When deuterium added by another amount of neutrons, magiging tritium siya. But pag fuse ng another proton, hindi na siya hydrogen, kundi tawag doon ay helium kasi dalawa na yung protons niya. The next type of nucleosynthesis is the stellar nucleosynthesis. So, ito naman yung formation of elements inside the stars. So, ano yung nabubuong stars? This is caused by nuclear fusion and electrons capture. So, stellar nucleosynthesis is responsible for formation of elements which is heavier than helium until iron. Mula helium hanggang iron ang nag-form sa loob ng stars, and it occurs through nuclear fusion and electron capture. So, the formation of hydrogen to helium is because of the process of proton-proton chain or the hydrogen burning. So, it is the fusion of 4 hydrogen nuclei to form a helium nucleus. So, let us take a look to this figure. Sabi dito, meron daw 4 na hydrogen at ang dulo ng reaction ay helium. It is proton-proton chain because it is involving a combination of the 4 protons in the hydrogen. So, in the process, nagkakaroon ng emission of positrons and releasing of gamma rays. Sa positrons, para siyang electrons, pero positive charge siya. Kumbaga, antimatter siya, parang kalaban siya ng electrons. So, pag nagbanggaan ang positrons at saka electrons, tapos mawawala. Pagkatapos ng process, nagkaroon ng 2 protons na nag-combine with 2 neutrons. Tapos yung dalawa sa 4 ay na-release. Itong dalawa na to ay pwede mag-join ulit into another proton chain. The next one is the carbon, nitrogen, oxygen or CNO cycle. It is the conversion of hydrogen to helium among massive stars using carbon as catalyst. So, let us see in the illustration, the CNO proceeds as follows. Step 1, carbon-12 captures a proton and gives off a gamma ray, producing an unstable nitrogen-13. Step 2, nitrogen-13 will undergo beta decay to form a carbon-13. Step 3. Carbon-13 captures a proton and it releases a gamma ray, nitrogen-14. Step 4. The nitrogen-14 captures another proton and releases a gamma rays to produce a oxygen-15. Step 5. Oxygen-15 undergoes beta decay and becomes nitrogen-15. So step 6, finally, nitrogen-15 captures the proton and gives off helium, which is an alpha particle, and ending the cycle, returning to carbon-12. So what happens once a star has used up the hydrogen in its core? So the proton-proton chain and the CNO cycle will no longer use or it being stopped. Helium starts to be expanded and burned. Helium is burned to produce a carbon through the process called tri-alpha process. So what is tri-alpha process? Tri-alpha process is a alpha particle is equivalent to helium atom. First reaction form unstable beryllium atom. So let us know how they fuses. So when two alpha particles fuses together and form a beryllium atoms, then the beryllium atom fuses with another alpha particle, then it produces a carbon-12. So through the process of tri-alpha particle, the carbon-12 atom was being formed. The next one is the alpha ladder process. It is additional helium burning reaction resulting synthesis or formation of heavier nuclei up to iron. So let us see how alpha ladder process works. So it start with the fusion of carbon-12 atom and alpha particle to produce a oxygen-16 atom. Then the oxygen-16 atom fused with another alpha particle to produce a neon-20 of atom. The neon-20 fused with an alpha particle with result a magnesium-24. Then the magnesium-24 atom fused with another alpha particle just to produce a silicon-28 of atoms. So each atom fused with alpha particle to produce a different kind of atoms. Pag ganun ang nangyari of electrons emitted or nawala or ang atomic number of the nucleus will be increased by 1. Di na siya yung tinatawag nating acid nucleus. For example, yung element na iron, pag nag-capture siya ng isa, let's say hindi siya nag-stable. So, ang tendency niya ay magre-release ng beta particles. So, when it releases the beta particles, it has a tendency to add a proton or to it is increase the number of protons. So, hindi na siya yung pang 26 or yung iron element, kundi isa na siyang cobalt element. So the last type of nucleosynthesis is supernova. Supernova nucleosynthesis is believed to be the reason for the formation of heavier nuclei after iron. The pathway for heavier nuclei to be formed through neutrons capture, not a nuclear fusion. So the reason why it called as supernova nucleosynthesis is because when massive stars exploded, all particles are in outer space and available para mag-combine or mag-capture just to form a higher or to produce a much heavier elements than iron. So neutron capture happens when neutrons is added to a seed nucleus. Pag ganun ang nangyari of electrons emitted or nawala or ang atomic number of the nucleus will be increased by 1. Di na siya yung tinatawag nating seed nucleus. For example, yung element na iron, pag nag-capture siya ng isa, let's say hindi siya nag-stable. So, ang tendency niya ay magre-release ng beta particles. So, when it releases the beta particles, it has a tendency to add a proton or to it is increase the number of protons. So, hindi na siya yung pang 26 or yung iron element, kundi isa na siyang cobalt element. So, the two types of neutrons capture, we have the S process or slow process and the R process or the rapid process. S process, addition of neutrons is so slow that beta decay happen before another neutrons is added to the nucleus. While R process, fast capture of neutrons before radioactive occurs. So here the summary of the formation of the chemical elements. First, the formation of light element during the Big Bang nucleosynthesis, where hydrogen and helium was formed. The formation of the heavy element. The formation of the elements from carbon until iron, known as the stellar nucleosynthesis, and it involves triple alpha process, carbon nitrogen oxygen process, and alpha ladder process. The element that heavier than iron was formed during the supernova or the explosion of the massive star, and it involves R process and S process. That's all for this discussion. So hoping that you have learned a lot from our topic, and thank you.